Alright, so here we have the board in its beauty. It has its heat sinks on. We already did the peeling away of the stuff. So we're going to start out by removing this and this. So these are M.2s. We did this last time, but yeah, so we're going to keep all the M.2 screws together. And in a bigger tray, you might be able to have more luck. This should come off pretty easily, and as you see here, these are molded correctly to the back of the PCB. They cool the PCB because the PCB has a lot of copper in it, and it absorbs a ton of heat from the voltage regulators. So you got nice thermal pads here, and then you can see residue here from the thermal pad, and that goes over. This is actually messed up because I've already taken this off, but this just cools the backside of the PCB. There's actually no chip under here. It's just cooling the backside of the PCB to basically cool the controller above it. So once we take this off, we put it aside. Okay, now you can see here you got these standoffs. 1, 2, 3, 4, and you got screws. 1, 2, 3. These are heatsink screws, and this is the 4th heatsink screws. We got to take these standoffs off. Okay. Now to do that, I just use this set, this pin, and then put it in here, and then put that in there, and then that little thing. Okay, here's your I/O shield. The integrated I/O shield. It's basically a real I/O shield, just integrated. So this is the cover. This is the only plastic part, and you see here it's basically held in through a plug, and this plug is 8 pins, I believe. Yeah, 8 pins, and you see all of that, all of those wires go in here. So that's what illuminates this. Yeah. So definitely make sure when you're putting this back together, if you do take it apart, that you plug it back in before you screw this back on. Otherwise, you're going to have not a good time. So here is the heatsink. Just pull up. You have your thermal pads here. They're embraced. You have a thermal pad here. Just like I said, that indent on the bottom was to cool the bottom of the PCB. This is to cool this tiny, tiny little chip right here. I don't know if you can even see that. That right there. We'll zoom in a little bit. But yeah, this is the heatsink. And it is all copper fin right here. This fins array 3, they call it the fins array 3. It's actually really nice. This should be direct touch, so let's check. Ooh, yeah, it is direct touch. I can see it here from a little bit, but as you can see, the thermal pad is coming apart as I pull it. So I might not want to mess with that, but yeah, it is. I can see copper down there. So this is the heatsink. It might look like this, like one piece is solid, but it's not. It's huge amount of surface area for dispersing all that heat. So it's fanless, which is nice. But yeah, it can be misleading, and like it's kind of runs stealthy with this on the side. You think it's like a solid piece of metal, but no, it's tons of tiny, thin copper fins, which is exactly what we want to see, because we want to see that. Because it causes a lot of air turbulence, and when you have more turbulence, you have more transfer of heat. So anyways, let's take a look at the back. We gotta take the one last heatsink off. So there's the thing, but you see how this thermal pad works. It only molds when it's heated, so when it's not heated, it acts like glue. You can't feel the glue, but it's there. So it cools this. I don't really mess with this stuff. But, yeah. There you go. The board is now nude. Alright, ladies and gentlemen, now we're going to take a look at the motherboard's nitty and gritty now that we've disassembled it. Here we can see that the VRM is right here. Let's switch this around so you can get a better angle of it. So right here is your PWM controller. Now Intersil and Renaissance, I guess they merged. I guess Renaissance bought Intersil. So now that this PWM is called the RAA, which is a Renaissance part, the 229131. The 229131 is basically a x plus y equals 20, or equals 2 or is less than 20. So here we have a 19 plus 1 PWM phases, no doublers. And one giveaway no doublers is that the VCC, the V core basically, is 19 phases. It's an odd number. You can't really have odd numbers with doublers, either through actual doubling by just double routing it, or doubling by using a doubler or a quadrupler. You can't have odd numbers. But here we have odd numbers. We know it's direct, and it's direct to that PWM controller. And then the VCCA is right here. The VCSA is here, sorry, and this is the iGPU. Now, if we're going to take a closer look, you have two power stages. They kind of look identical. This is the graphics, the VCC GT. Now, that is an Intersil part, the ISL 99390. That's a 90 amp part. These are the rest, the 19. They're also a RAA part, so it's a Renaissance part. It's an RAA 2010540. Those are 105 amps each. So you got 19 phases of 105 amp power stages. Here you have a monolithic power solution. You have a PWM controller. I believe it's an MP2940. It's found on some graphics cards. It's right here, this little chip. And then you have two power stages. These are driver MOSFETs. They're rated 70 amps each, and they are the MP87992. Yeah, you see this on some graphics cards, some motherboards as well. Now, that's the voltage regulator area. You got more copper in the PCB. You got tons of capacitors, inductors. All cool. Very powerful. Really nice heatsink on this motherboard. So let's take a look here. So now that we're up here, and you guys can see this kind of centered in the image, we'll start over here. This is an Intel controller, and it is the AX210 Wi-Fi 6E / Bluetooth 5.2. So this takes care of your Wi-Fi and Bluetooth needs. Now this is a Realtek controller. This is a hub, a USB 3.0 hub. So the chipset sends a USB 3.0 signal. USB 3.0 is now known as USB 3.2 Gen 1, 5 gigabits per second. You get 4 ports on the back that are blue, these. And they all come from that hub. I think it's the RTS 5411. Yeah, RTS 5411. There are 2 of them actually. One here, and then another use for the front panel I'll show you. Then you have a little PI3, which is a Paracom part. It looks like a P and a 1, but it's a PI3. I think it's EQX. It's a smaller, it's a redriver for USB 3.2 Gen 2, which is 10 gigabits per second, otherwise known as USB 3.1. So it helps redrive some of those signals from the PCH. You also have a hub. So 3 of the ports on the rear I/O actually get their bandwidth from a USB 3.2 Gen 2 10 gigabits per second hub. One of them is a Type-C controller, the Type-C port, and that little Paracom probably helps with that. And 2 of them are Type-A. So you have 6 total USB 3.2 Gen 2 on the back, which are 10 gigabits per second. 2 of the Type-A and the Type-C are basically through this hub. The RTS 5420, I believe. Yeah, I think that's correct. And one of the Type-Cs, and then 3 of the Type-A's are directly to the chipset. Now, we also have a Type-C port that is a USB 3.2 Gen 2 by 2, so it's basically 2 Gen 2 links. Now that requires a special redriver and a Type-C controller and power delivery 3.0 controller. So the controller is an IT8851E, and that's this little tiny thing right here. And then this is your Paracom, basically it's a PI3 again, EQX 2004 series. This is specifically made for redriving 2 lanes. So there you get your 10 gigabits, and it's that port underneath the 1 gigabit LAN, which we'll talk about now too, because we're right here. This is a little bit harder to see because this is probably the smallest, most powerful I see, well, other than the CPU processor and probably the chipset, on the motherboard. This is your 10 gigabit NIC from Marvel, and Marvel must have acquired a Quinta. So this is the AQC113C. It is tiny, it is hot, that's why it's cooled by both the top and the bottom with like 3 screws on the bottom securing the cooling solution for this. Direct touch into that huge heat spreader, or the heat sink used for also the VRMs. Although I'm pretty sure it can't output that much, it's just probably a high temp. Yeah, so going over here, I guess we can cover audio for now. You have an ALC 1220 right here from Realtek. Now this is a very common chip and it's been used for a while, right there. And right here you have an ESS Sabre DAC. Now this is the ESS, it's the 9118, 125 decibel SNR, signal noise ratio. You got your WEMA audio film capacitors. You have these Nichicon electrolytic capacitors. So here's your audio section. It's separated. It uses a solid oscillator right here to generate the correct frequency signals. Now, I guess we'll move down like this. So, I guess I'll move it up and it looks down to you. This is an ITE chip. I think this is one of the ECs. Now, this EC, I believe, is used for, this is a supplement to this EC right here. This is, but this is your Super I/O chip right here. This is the IT8692. Yeah, this is the, no, sorry, it's the 8689, sorry. And this is the IT87952. So this basically controls all your fans and everything. Fan control, it controls a lot of system stuff. And then this right here supplements it with extra support and RGB, stuff like that. Probably the multi-key function right here, you can see is also using this. You have a chip here. This is Genesis Tech. And that's a GL850G. This is a very common USB 2.0 hub. So basically it takes, right here, it takes a USB 2.0 and creates these 2 ports here for USB 2.0. Moving along, here we have an embedded controller. This controller has been found on a lot of motherboards by Gigabyte. It is an IT5701E. It's an embedded controller and it basically it allows for QFlash Plus of this single 256 megabits, 32 megabyte BIOS ROM. So it's a single one. The press of a button in the back, this will imitate a system and allow for flashing of this through that single USB port on the back without a CPU or DRAM installed. You need power though, you know. This battery ain't gonna power much. But this is your CMOS battery. These are like low profile. So, anyways, so remember we said earlier that these two switch. Now, this one specifically switches with this M.2 slot between two SATA ports, not between two SATA ports. No, these switches are here. This is your ASM 1480s here, PCI 3.0. So basically those switch between this slot and this. So these two switch PCI by 4 by these two ASM 1480 by 2 PCI 3.0 quick switches. Now here, we have a quick switch for PCI 4.0, right? And this PCI 4.0 switch is pretty good. It's a PI3 DBS and DBS 1614 basically. So it's a PCI 4.0 switch. It switches between 2 lanes of SATA, these two. Let's bring it more into view. These two with this, they switch, and this switches them. And then this little controller chip is an IT87. No, it's not. It's an IT5706EN. So it gets a signal, and then I guess you could choose. So when you choose one or the other, it will switch between these two. So this controls this chip. So moving along, remember we had that Gen 2 redriver? Well, we still have it here. Remember we had that IT chip right there? We still have it. So this is another IT8851E. This little thing, a Power Delivery 3.0 controller for this Type-C port. And then you also have this Pericom PI3 EQX2004 Gen 2x2 redriver for this. Moving along, we have another Realtek RTS 5411, and that supplies these two USB 3.0 ports. Now, going up here, I believe this is one of the last things we have to cover, and this is an ON semiconductor. Can you see that? Yeah. This is an ON semiconductor, basically all-in-one PWM plus high side, low side FET. Now this can take in a range of 4 to like 20 something volts, and then convert it to as low as 0.6 volts. It has a high switching frequency, it's rated 15 amps, and as you see, no one put a heatsink on it, so it probably doesn't get that hot. It's for DDR5. DDR5 has its own power management IC on board. It takes an input voltage, which is basically from that on semiconductor chip here. It's like single phase VRM all in one, and it can change that into all the other voltages like VDD, VPP, all that stuff needed for DRAM. And I believe Gigabyte actually gives the option for you to change the input voltage like you would to an older style CPU that uses an integrated voltage regulator, the FIVR, FIVR on the old chips. And it allows you to change that input voltage a little bit, I believe. I think it was touted as one of the things. Yeah, so that's the board. There's the nice VRM again. Here's the other stuff. And on the back, like I mentioned, you got some SMT stuff here. The routing, as you can see here, is very clean in this area. Okay? Very clean. And that's on purpose. Now you see here, all these are through holes. You got your PCIe right here, which are through holes. Now these little metal things go all the way to those bottom 2x4 slots. On PCI 3.0 this is fine. Even on PCI 4.0 this is fine. These are 3.0 though. But for PCI 5.0 it's not fine. When these come out, okay, the bandwidth is so high that, or the signaling is so sensitive, sorry. The signaling is so sensitive that it'll pick up electrical noise on these little things. Okay? So basically you use SMT, which is surface mount technology. So this is where that slot lies. You can see the anchors here and here, as well as the other anchors SMT. And these anchors basically hold down the PCIe slot, but then this is your by16, and you can see the routing here very clearly on the top. And then if we flip this thing over, we can see the same routing right here. So this is a clear lane. And see, PCIe, Thunderbolt 3, stuff like that, they have distance measurements that are pretty strict. So you can't be that far without a bunch of redrivers and such. And so we look forward to looking at the future boards with more PCI 5.0 signal protocols to see what board vendors come up with. We're probably going to see a ton of redrivers and some pretty high-end switches if anyone's going to move around that PCI 5.0. Anyway, so you got SMT on your DIMMs right here. You got SMT here. And I think we covered pretty much everything on this motherboard. So yeah, say hello to the Gigabyte Aorus Master. Anyways, if you have any questions and comments, please comment below, or just go on the website and leave a comment there too if you want. Anyways, thank you for watching, and we hope you have a great day.